Welcome to Antennas and Microwave Engineering lecture series. In this session, I am going to explain about composite filter and its MCQ questions. So first of all, what is composite filter? Composite filter is an electronic filter which consists of multiple image filter sections of two or more different types. Okay, the meaning is இந்த காம்போசைட் ஃபில்டருக்குள்ளே எப்படி இருக்கும்னா இட் கன்சிஸ்ட் ஆஃப் நிறைய செக்ஷன் இருக்கும். அந்த செக்ஷனில் விதவிதமான ஃபில்டர்ஸை கம்பைன் பண்ணியிருப்பாங்க, டூ ஆர் மோர் டைப்ஸ். தட் இஸ் கால்ட் காம்போசைட் ஃபில்டர். ஓகே, ஸோ let's see why they are going for this composite filter model. Okay, so this is the graph which is drawn between the frequency and the attenuation rate. Okay, so I told you the filter is mainly based on two band of frequencies. One is passband, another one is the stop band. So in the constant K filter, one of the drawback is a low attenuation rate at the stop band. So that problem is avoided by this m-derived filter section. In the m-derived filter, they are utilizing two frequencies. One is Fc, another one is F infinitive. Fc represent the cutoff frequency and F infinitive represent infinite attenuation pole point. Infinite attenuation pole point. Okay, so what happen is, of course, in the m-derived filter நமக்கு என்ன கிடைக்கும்னா sharp cutoff frequency கிடைக்கும். ஆனா once we are increasing that frequency, it reaching at F infinitive, அது வரைக்கும் attenuation rate வந்து அப்படி ஷார்ப்பாக போயிட்டு இருக்கும். Above that F infinitive value, okay, if it is a low pass filter value, the attenuation rate is drastically reducing. Okay, but we need sharp cutoff. So this is the drawback of m-derived filter as well as the constant K filter. So that two concept is overcome by this composite section by connecting two bisected matching section in both ends. Okay, I will show you the block diagram of composite filter. Now this is the block diagram of composite filter. I told you know the drawback of m-derived and constant K filter section is reduced or solved by connecting two bisected matching section in both ends, which is where m equal to 0.6 the value. Okay, but in between they are utilizing two filter. Now see this two different types of filter. One is constant KT filter, another one is m-derived filter. In the m-derived filter, in between section, m value must be less than 0.6. M represent midpoint impedance. So when you connecting like this, the image impedance will be automatically matched. So ZIT represent matched image impedance. Okay, now in the previous videos, I explained about constant K filter, T section as well as pi section model, and m-derived T section and pi section model. So I'm going to explain about what's the bisected matching section. If it is a low pass filter, அப்படி இல்லைனா high pass filter. இப்போ low pass filter இருந்தா left sectionல இருக்க diagram நீங்க எடுத்துக்கலாம். So low pass filter, as you familiar, series arm consists of inductor, the parallel arm consists of capacitor, but here the capacitor connected with the inductor in series in the shunt arm. Okay, and the values are mc divided by 2 and 1 minus m square divided by 2m into L. This is called bisected matching section. In the left side showing this diagram, no, this is for low pass filter. If it is a high pass filter, now this is the diagram. High pass filter, you familiar, series arm capacitor will come, and in the shunt arm inductor, but in here inductor in series with capacitor, the value is 2m divided by 1 minus m square into C. This is the value of the capacitor which is present in the shunt arm of high pass filter. Okay, this R0 represent the image impedance. When you matched this composite filter with this bisected matching section, the image impedance R0 will be matched automatically. Okay, so problem la eppadi keppanga by m-derived filter composite filter section la what's the value of m. Similarly for bisected matching section கேட்கலாம், and two types same type use பண்ணுமா இல்லை different types of use பண்ணணுமா, இந்த மாதிரி questions கேட்கலாம். Otherwise in the circuit வரைஞ்சி they will ask any one of the component, find the capacitor value or find the inductor value which is connected in parallel or which is connected in series, like that the question may become. Okay, so based on that, these are the MCQ questions regarding with composite filter. Now the first question is, which value of m is selected in a composite filter while connecting the terminating sections in order to acquire proper impedance matching and constant characteristics impedance throughout the passband? A 0.3, option B 0.6, option C 0.9, and option D 0.12. Now see the question. M is selected in a composite filter while connecting the terminating section in order to acquire proper impedance matching. Proper impedance matching, the M value must be 0.6 in the matching section. So this is the answer. Now the second question, which filter is not used in composite filter design? Option A, constant KT section, option B, m-derived section, option C, pi by 2 matching section, option D, constant K pi section. And now see these three options. இப்போ first one பார்த்தீங்கன்னா constant KT section யூஸ் பண்ணியிருக்காங்க, m-derived section, pi by 2 matching section இருக்கணும். ஆனால் which filter is not used னு கேட்டிருக்காங்க. So the answer is constant K pi section. Actually when you see this block diagram of composite filter you can understand. So the answer is constant K pi section. Now the third question, in composite filter matching section at both ends are reciprocal, different, same, and commutative. The answer is both ends are same. Now the fourth question, it is possible to overcome the drawback of m-derived filter by connecting number of section in addition to prototype and m-derived section with terminating. Option A 1/4 section, option B half section, option C square of 3/4 section, option D full section. The answer is half section. The meaning is உங்களுக்கு m-derived filter drawback என்ன? Of course we will get sharp cutoff at FC, but when you are increasing the frequency, when it will reach the infinite attenuation for pole point, that means f infinitive. After that f infinitive, if it is a low pass filter, the attenuation is drastically reducing. Okay, so அதை அவாய்ட் பண்ணுறதுக்காக கண்டுபிடிச்சது தான் காம்போசைட் ஃபில்டர். காம்போசைட் ஃபில்டரில் என்ன யூஸ் பண்ணியிருப்பாங்கன்னா ரெண்டு பைசெக்டட் மேட்சிங் செக்ஷன் யூஸ் பண்ணியிருப்பாங்க, half section. Okay, that is called prototype. Okay, so match பண்ணியிருப்பாங்க. So due to that we can solve the problem of m-derived filter drawback. So the answer is half section. Now the fifth question, the connection between matching section constant K m-derived section in composite filter is option A cascade, option B cascode, option C Cannizzaro, option D Casario. See, I already explained in the previous videos itself, the filter designs are cascade connection. Cascade means one section output is connected as an input of the second section, like that the chain will go. Okay, so the answer is cascade. Now the sixth question, the matching section in composite filter is shown below, find the value of inductor. So இந்த மாதிரி questions வரும், அதாவது matching section ஓட diagram கொடுப்பாங்க, இந்த arrow இப்போ indicate பண்ணுறது inductor, sometimes they can ask the capacitor. So in the question they doesn't provide any values, but in the diagram itself they are showing the value. Okay, inductor ஓட value ml/2 கொடுத்திருக்காங்க. We have to find the value which is present in the section 1 minus m square divided by 2m into L. Don't think that இப்போ m ஓட வேல்யூ போட்டு இதிலிருந்து L மட்டும் தனியாக பிரித்து எடுத்து Lன்னு போடுவோம். It's not like that. இந்த செக்ஷனோட இண்டக்டர் வேல்யூ என்ன? 1 minus m square divided by 2m into L. Suppose they are asking capacitor, don't think that C. இந்த செக்ஷனோட capacitor வேல்யூ என்ன? mc divided by 2. Okay, right? So based on that, the question itself they provided is a matching section. These are the clue they are provided, and the options are option A 174.21 nanohenry, option B 165.45 nanohenry, option C 156.76 nanohenry, option D 169.76 nanohenry, and the answer is 169.76 nanohenry, and I will show you how we are getting. Now I told you, in the question the given data is ml divided by 2 equal to 95.493 nanohenry. Okay, and we have to find the inductor value of the ohm, 1 minus m square divided by 2m in the L. Okay, so it's a matching section, therefore matching section composite filter m equal to 0.6. Okay, so From ml by 2, the values are there. So I am cross multiplying with 2 and I am getting ml equal to 190.986 in the 10 to the power minus 9. And when I am substituting the m value, which is equal to 0.6, I am getting the L value is 318.31 nanohenry. Okay. Now I am substituting that L value in the formula 1 minus m square divided by 2m into L. When I am substituting all the values, I will get 169.76 nanohenry. Thank you so much for watching this video. If you like my video, kindly subscribe my channel.